Here's a question that sounds simple but often trips up even experienced Python developers. What's the difference between a shallow copy and a deep copy? Now, both of these make copies of objects in Python, but they behave very differently, especially when your data is nested. Let's keep it simple. A shallow copy makes a new outer container, like copying a folder, but all the files inside still point back to the same originals. So if you change something inside, both folders reflect that change. A deep copy, on the other hand, doesn't just copy the folder, it duplicates everything inside it too. Each file, each subfolder, brand new and fully independent. That's the key difference. Shallow copy 12 shares inner references. Deep copy 12 creates completely separate objects. Interviewers use this question to test if you understand how data is linked in memory, because that can make or break your pipeline's reliability. Let's break this down with an example. Imagine you have a list of lists, like a dataset with two small tables. When you make a shallow copy, Python creates a new outer list. But the inner lists, the tables themselves, still point to the same memory. So if you update one table in the copied version, the same change appears in the original, even though you didn't touch it. Well, now, when you use a deep copy, Python duplicates everything, the outer list and all the inner lists inside it. Now the two are completely separate. Changes in one don't affect the other. That's why deep copies are essential when working with nested data, like dictionaries inside lists or configurations inside models. Let's see how this matters in real life. In one of my A/B testing projects, we had a configuration dictionary for each experiment variant, A and B. Each config had nested parameters for model settings and data filters. At first, we made a shallow copy of variant A's config to create variant B. But when we tweaked one nested value for variant B, it also changed inside variant A, because both shared the same inner reference. That bug silently broke our test results. Both experiments were running the same setup. After that, we switched to dceap, which created truly independent versions of each config. That small change prevented the overlap, gave us clean results, and saved hours of debugging time. Here's how I'd say it in an interview. In one of my experiments, I used DC to create separate configurations for two A/B test variants. Before that, using a shallow copy caused the nested parameter dictionaries to share references. So updating one variant changed the other. After switching to deep copies, each configuration became independent, and our test results were finally reliable. That answer shows you understand not just what shallow and deep copies are, but also why they matter, especially when you're working with nested data structures in machine learning or analytics.